Welcome to this explainer. Today, we are treating the Cambridge Mathematics syllabus exactly like what it is, the ultimate championship final. You have 90 minutes to glory, and what we're going to build today is your ultimate game plan for exam victory. Now, if you've been working your way through the Cambridge system, whether you started building your foundations back in syllabus codes 0580, 0606, 4024, 4037, or 4040, you know that the pressure really ramps up at the ASNA level. Today, we are specifically targeting syllabus 9709, and we are going head-to-head with what many consider the final boss of the paper, differential equations, specifically separating variables. You know the drill, getting your y's with your dy's and your x's with your dx's. It can honestly feel incredibly overwhelming. But what if I told you that it doesn't have to be? What if you could literally hold the examiner's exact playbook in your hands? Well, today, that's exactly what we are doing. We are going to completely demystify the grading process and reveal exactly how to secure those top-tier marks. Okay, let's dive right into this.
So, right off the bat, we have to ask the big question: why do so many smart, capable students drop vital, highly preventable points on separating variables? I want you to imagine two different students. We'll call them Alex and Sam. Now, Alex is the kind of student who overloads every answer with raw mathematics facts. Alex has memorized every single integration rule, but provides absolutely no analytical structure to the answer. It's just a brain dump onto the page. Then we have Sam. Sam's problem is different. Sam panics, rushes through the paper, and completely misses the specific command word requirements in the prompt. Both Alex and Sam walk out of the exam hall feeling confident, and both of them end up with red ink all over their multi-stage differential equation answers. You might think losing marks here is just about messing up a tricky algebra step or forgetting the constant of integration, but the truth is actually much, much deeper. Most students are just playing the wrong game entirely. By the end of our time together today, you are going to have an ironclad game plan to ensure you aren't leaving these easy marks on the table. Here is our step-by-step game plan for today. We're going to start with number 1, the challenge. Then we'll break down number 2, the core cognitive domains. After that, we'll reveal number 3, the blueprint. Then we move into the real secret sauce with number 4, the method mark strategy. We'll follow that up with number 5, the top 3 pitfalls. And finally, we will wrap it all up with number 6, mastering evaluative thinking.
Okay, section 1, the challenge. Let's talk about the massive gap between what candidates think the examiners want to see and what is actually being graded on that paper.
If you take nothing else away from this first part, remember this exact phrase: analytical depth over superficial breadth. This is the absolute core of the challenge. The academic benchmarks for separating variables do not just require you to know a scattered handful of mathematical facts. They demand logical, highly structured reasoning. Think back to our student Alex from earlier. Alex was relying entirely on superficial breadth, throwing every known equation at the wall and hoping something would stick. But the assessment framework heavily prioritizes deep, analytical understanding over a surface-level grasp of a wide range of topics. If you're just memorizing integration formulas without genuinely understanding the underlying mechanics of setting up the differential equation from scratch, you are going to hit a brick wall. The examiners are specifically designing these questions to weed out the candidates who just memorize from the candidates who actually understand the math.
Moving on to section 2, core cognitive domains. If you want to beat the game, you absolutely have to know how the points are scored. And the examiners are actively targeting specific cognitive areas when they look at your paper.
There are 3 distinct cognitive domains at play in every single exam question: knowledge and understanding, application, and analysis. Now, your theoretical architecture relies on the first one. You need precise definitions, and you need to know your integration techniques. But, and this is crucial, it absolutely does not stop there. You have to understand the causal relationships, and you have to be able to deeply apply that core knowledge to complex, multi-stage problems. You aren't just a calculator executing a function, you are an analyst who is actively proving a mathematical relationship. You need to decode the command words in the question to figure out exactly which domain the examiner is testing at that exact moment. Before we continue, subscribe to our YouTube channel, Ace the Exams, at AC Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, section 3, the blueprint. Now that we know exactly what the examiners are looking for, let's reveal the definitive procedural framework. This is your step-by-step methodology to tackle any separating variables question systematically.
Here is your standardized sequence. Step 1, deconstruct the question. Look closely at those command words. Step 2, extract relevant data. This is where you pull out your boundary conditions or initial values. Step 3, select your analytical framework. Step 4, execute with clear notation.
And step 5, present with correct terminology. I want you to pause for a second. Think about the Peel framework from your essay subjects. Point, evidence, explanation, link. What we have here is essentially the mathematics equivalent. I challenge you right now to create a mental mnemonic with the first letters of these steps, D, E, S, E, P. Locking this 5-step sequence into your memory is a massive leap toward total exam mastery. If you follow this, you will never stare at a blank page again.
Let's move to section 4, the method mark strategy. Honestly, this is perhaps the most critical secret weapon in the examiner's playbook. This is where we turn those red pen marks into green check marks. Let's define the method mark strategy. It is an assessment principle where marks are awarded for demonstrating the correct analytical process and executing clear working, not just for achieving the final mathematical answer. Let that sink in. In multi-stage analysis, strictly following your procedural framework to show your analytical processing is vital. I've seen students who somehow manage to jump to the final integrated equation in their head, write down the correct final answer, and get 1 mark out of 6. Why? Because they got 0 method marks. You have to show the examiner exactly how your mind is working, step by step. You have to clearly show the separation. You have to show the integration on both sides. This is your true mathematics success blueprint. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now we're into Section 5, Top 3 Examiner Warnings. We have gone directly to the Cambridge Principal Examiner reports to see exactly where candidates consistently stumble and lose their marks.
The reports are incredibly clear on this. There are exactly 3 fatal mistakes that ruin otherwise excellent, highly prepared exam performances. If you can avoid these 3 traps, you are already ahead of the vast majority of candidates sitting in that hall with you.
Here are the 3 major pitfalls. Warning number 1. Examiners report that students frequently confuse cause and effect when initially setting up the differential equation. They get their proportionalities backwards. Warning number 2, students get sloppy. Remember Sam from earlier? Rushing through? When you rush, you forget to check your format. You inevitably drop the constant of integration, and your notation becomes an absolute mess. Strict mathematical conventions matter here. And warning number 3, providing generic answers that lack specific context. You'd be amazed how many students do all the hard calculus flawlessly, but then fail to actually answer the specific scenario posed in the question. Let's look closer at that last one. The absolute classic mistake is providing a generic mathematical answer that isn't specific to the context. What is the top scoring strategy? It's simple. Always link every single calculation directly back to the given scenario. If the differential equation you are working on is modeling population growth or maybe Newton's law of cooling, your final presentation and the specific variables you choose to write down must actively reflect that real-world context. Don't just leave it as y and x if the question specifically asked about temperature T and time lowercase t. It's a tiny detail, but it's exactly what separates an A from an A star. All right, we have reached Section 6, Mastering Evaluative Thinking. This is for the final push. This is how the absolute top-scoring candidates elevate their answers through deep critical analysis. I want you to hear this quote directly from the source, from the Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. Listen, the architecture of separating variables does not exist in a vacuum. Integrating differential equations with other areas of the syllabus, like kinematics or complex trigonometry or partial fractions, is exactly what unlocks the highest tier of marks. The examiners are practically begging you to show them that you understand how the entire mathematics syllabus connects together as one cohesive system. So how do you actually show them that? You need to use comparative critical analysis. You must identify similarities and differences within the mathematical models you are building. You need to support every single analytical leap with concrete mathematical evidence. And finally, you have to draw conclusions about your results. Top candidates demonstrate this evaluative thinking by constantly questioning their own assumptions, rigorously checking their boundary conditions, and verifying if their final equation actually makes logical sense within the constraints of the problem. If you calculate a negative population or a mass that grows infinitely when it shouldn't, you need to catch that. You need a solid time management matrix so you actually have the minutes left at the end of the exam to do this level of verification. So I'm going to leave you with a provocative question to think about. Are you just trying to blindly solve equations, or are you finally ready to master the examiner's game plan? By applying this complete methodological blueprint, focusing on analytical depth, strictly securing those method marks, and utilizing high-level evaluative thinking, you aren't just doing math anymore. You are executing a winning strategy. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at @ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.